talking about compound events. Okay, 19.4. All right. Compound events consist of two or more outcomes. Okay. For example, I'm going to roll a number cubed or a dice and get the number 2, and I'm going to pick a card from a 52 card deck and get a king of spades. Okay. That's what I want to happen. Okay. Well, there's got to be a way to figure out what the probability of that would be. Okay. We already know how to figure the probability of each event. Okay. We know how to figure the probability that I roll a number cube and get a 2. The probability of rolling a 2 on a number cube would be what? 1/6. Because there's one number 2 on the dice, and there's 6 total numbers on the dice. So it would be 1/6. Now, what people have a tendency to do is they put the number you're looking for as the top number of your probability. Okay, in other words, if I was looking for I was going to roll a 3, they would put 3/6. No, there's only one 3 on the dice. If you put 3, then that means you would believe that there's three 3s on the number dice. Okay, so compound events are when 2 or more things you want to happen. Okay, so that's what a compound event is. There's 2 types of compound events: dependent and independent. Okay, dependent and independent. Okay, a dependent event would be this. Could it snow today? No. Why? Not cold enough. Okay. It's not cold enough today to snow, so for it to have a probability of snow, we'd obviously have to be a lot colder. Okay, so that's a dependent event dependent upon what the temperature is. Okay, that's a dependent event. An independent event, for example, if I'm going to roll a 3 on a number dice and then pick a king of spades out of the deck of cards, does one have to occur for the other one to occur? In other words, do I have to roll a 3? Could I still pick a king of spades out of the deck of cards even if I roll a 2? Okay, yeah, I could. So those events are independent of each other. Okay, they're independent of each other because one does not rely on the other. Okay, now, they're going to give you a couple of different things today, and they're going to talk about a couple of different ways to figure compound events. Okay, let's look at the first one. Bear with me 1 second here. That one. All right, let's look at this example out of the book. Okay, they have given us here, they've given us a spinner and a number dice. Okay, it says for tossing a 1 to 6 number dice, okay, or number cube, and spinning the spinner, find each probability. Okay, so here's how we're going to do this. First one here, Number 1 says they want the probability that you're going to roll a 1 and spin blue. Okay? So, the probability that I'm going to spin the spinner and land on blue, then I'm going to roll the dice and have a 1. Okay, so what we have to do is we have to figure each probability first. So the probability of rolling a 1, what is the probability of rolling a 1? Isaac? 1 over 6. Okay, now we want to figure the probability of rolling a blue, or spinning a blue. What is the probability that I'm going to spin the spinner and land on blue? Michael? 1/4. Now, to know the joint probability, okay, to know the joint probability of 1 and blue, we simply take 1/6 times 1/4. Okay, what is 1/6 times 1/4? Remember, we're multiplying, so we don't have to have common denominators. What? 1 over 24. Okay, so the probability of rolling a 1 and blue would be equal to 1 over 24. Remember, if we can, you always simplify the fraction that is your probability. Okay, every time. All right? So, fairly simplistic. Okay, probably could do most of that in your head. Well, let's look at number 3. Number 3 says, find the probability of yellow and an odd number. Okay, well, first of all, we're going to find the probability of yellow. What is the probability that you spin yellow? Jonah? 1 over 4. Okay, now we got to find the probability of an odd number. What is the probability that I'm going to roll an odd number? Noah, which is 1/2. Okay, so now to find the probability that it's yellow and odd, that would be equal to 1/4 times 1 over 2. And that would be what? 1/8. Okay, now those are independent events. Okay, so we're talking about the probability of an independent event. Okay, it is different. Okay, it is different for a dependent event. Well, where'd it go? Try it again. All right, now, this is a dependent event. Okay, let's look at the directions for this one. It says, excuse me, use the cards to find the probability of each compound event. The first card is not returned before the second card is picked. Okay, so they're assuming that whatever your first instance is, it happens. For example, And number 4, they want the probability that you're going to pick a blue card. Okay? They're assuming that that happens. And you take the card out and you leave it out. Okay? The formula is still the same. It's just a little different with your numbers. Okay? So, for number 4 then, you take the probability of blue and then yellow. Okay? That is equal to the probability of blue times the probability of yellow if the first card is not returned. Okay, so let's look at the probability then. What is the probability of blue? That I pick a blue card. Staley. 2/6, which is 1/3. Okay, because there's 1, 2, 3, 4, 5, 6 cards. Okay, there's 2 blue cards. So that's 2/6, which we reduced to simplest form to 1/3. Now, we have to assume that this blue card is no longer there. We have to assume that what we wanted to take place happened. So now we have 1, 2, 3, 4, 5 cards that are left. So what is the probability that you're going to choose a yellow card? Jonah? 1/5. So this is 1/5. And you multiply those two things together. And when you multiply those two things together, you get a probability of what? 1/15. Okay? So that is a dependent event. Okay? The first one we did, this one up here, was an independent event. Joy? Because we're assuming that when we picked it, that it was the blue one, and we're keeping it out. Okay, whatever first card you pick, you're going to keep it out of the group, because it's a dependent event. Because they want you to get the first thing, they want the first thing to happen before the second thing happens. With the dice and the spinner, I can spin the spinner and not get what I want and still get the other probability. I can still, in that case it was dice. Okay, but this case they're saying it's a dependent event. So I'm going to reach into this box, I'm going to pull out a card, and I'm going to keep it. Then I'm going to reach into the box and pull out another card. And then I'm going to look at the two and see if I got what I wanted. See if I got the blue card and then the yellow card. Okay? Emma? No. Each problem itself is a totally different problem. So now that let's do number 7, okay? Or excuse me, number 6, not number 7. Number 7 not even there. Okay, so now we're back at number 7. So we're going to take and erase all my numbers. Now we're back to another problem. So we're back to 1, 2, 3, 4, 5, 6 cards. Okay, now number 6 says, what is the probability of yellow and yellow? Okay, Well, the probability of yellow, first of all, times the probability of yellow, second of all. So the probability of yellow in the first one is what? 1 over 6. Times, well, if I keep the yellow card, that means that card's no longer there. What is the probability that the second one will be yellow? 0 over 5. Okay? Well, what is 1 times 0? What's 6 times 5? 0 over 30 is probability of yellow. Can't happen. So I'm going to keep the first card. Okay? I'm going to keep the first card. We're assuming that it was a yellow one. It happened. There are no more yellow cards. So there's no way to pull out 2 yellow cards out of a stack that only has 1 yellow card in it. Okay? So that's the probability, 0. Now, you put 0 over 30, that's okay, but you really just need to put 0. Okay? It's not wrong, but it's just 0. Because realistically, if you have 0 over 30, it's not simplified. 0 over 30 simplified is 0. All right? So, not real hard. It's sort of easy. Just a matter if you can keep up with what's going on. All right? So, I'm going to turn you loose on your homework. Still got about 20 minutes left in class. I know some of you got a baseball game tonight, and so we'll try to give you some extra time to get this done. We're going to do 19.4, 1 through 17. You're going to do it on your own. No group work. Yes, sir. No problem. All right, so go ahead and get started on that. Like I say, we've got 20 minutes left in class. You ought to be able to get most of it done. If you have questions, raise your hand, and I'll come and help.